Hello, everyone. We are the first group of planning and strategy. Our topic is optimize the reflect and reflectives Saga large language model. The reason we chose this topic is that the professor has already introduced the Saga large language model in the class, and we found that it has lots of advantages. So we take it into our consideration and propose this topic. And here are our group members. We start from the single large language model. For the single large language model, it has a high speculation, generally speaking, and it has a simple question. It can answer the simple question, which means that the one answer corresponds to one question and is really specified. Just like the capability of evaluation of most popular AI tools, as it shows here, for ChatGPT, it almost do everything well in this chart. But for Claude, there are still some fields it cannot be performed well here. So if we want the large language model to process the even harder information, we need to get the multi-agent system, which means a traditional multi-agent system is a combination of the different types of large language model. And it also contains the collaboration between them. So what can we handle the error during this running of different large language model? We use the Saga large language model because it's creatively proposed a rollback and a compensation mechanism. For the Saga large language model structure, it contains 5 parts. The first one is agent. An agent that performs a specific task is able to complete the assigned work according to instructions and collaborate with other components. And the Saga coordinator, it manages the transaction execution process and ensures compensation operations and rollback in case of the failure. And for the context manager, it's responsible for maintaining and updating the system state, and for validator, it verifies the correctness and the consistent of the agent's output and use the independent small content agents for strict verification. For the reflection agent, it analyzes the execution process, identify error patterns, provide improvement suggestions, and enhance the system's adaptive capabilities. So what is the detail about the rollback and compensation mechanism? It contains 4 parts. The first one is the task execution, which means that it executes the task in order of the dependency. And for the context manager, it records the state of the change in the system. And the validator will real-time verification of the execution results. It means they need to detect whether there are some error found in this process. And also for error detection, the execution result was found to be inconsistent with the expectations. And for the coordinator, it designs the triggers, the rollback process, and for the system looks current execution state. For the rollback path, it perform the compensation operation in the reverse order of the dependency graph, which means that if this step cannot work, we need to back to the previous step, and each agent has a corresponding compensation. Right? And it also has the part of replan. The reflection agent, its analysis the reason of error, and it make new execution strategy, and the system resumes execution from a consistent state. It can guarantee that it will not make any mistakes in the later steps after this one. And now let my partner to introduce the innovation breakthrough, our core advantages.
Let's talk about some creative things we have added in our structure. Next page. First, let's talk about the limitation of the traditional validation. First, in the Saga large language model, we only check if the large language model gave us the correct format and the type of answers, and then it cannot give us a method to test the result if feasibility. For example, the agent B have to give the answers based on the answers given by the agent A. And if agent A give answers with many constraints, the agent B have to give the answers under these constraints. So we have to make sure that every output have flexibility is very good. And then is no feature prediction. We can't get the answer if this answer is correct until each of the agent give you the answer, and we see the all process. We can judge that if that is correct or not correct. So this validation cannot be predictable. Next page. And then we add a new layer called review optimization layer. First, we after every agent give the output, we add one layer to evaluate the test feasibility and mark the risk label. For example, if the agent A give me an answer, I don't pass the answer to agent B directly. I'll add another large language model to evaluate if this answer with high risk to failed or low level risk. If the large language model said that this test is easy, it's easy to lose, then we will keep this output and the reason given by the new large language model to give back to the agent. You have your answer, you have the reason. Just like a human, the human process to thinking about that. Your answer is not good, and the reasoning you also have, you can change and advance your answer until you give repeat and repeat. They will give until you give me more risk level answers, and then we pass it to another agent. However, if they don't give us if after 3 times or sometimes you said they didn't give us more risk levels, they will start the rollback process. Next page. And you can find that our output can after our new layer, we can predict the answer before we get the all process, and it can give you a better and more logic answers, because they can change, they can advance, not just directly give you answer. Maybe it's hard to make sure. Next page. And finally, after we do either A/B test to test the widening planning example, and we can the outputs to test if our new structure is useful, and we can find that it have favor rollback and more times successful and more risk. Let's move to my partner's job.
Integrate on our previous established context memory and rolling back mechanism and optimization layer with the Saga large language model structure. We have built an end-to-end system. This system following a workflow that begins with receiving neutral language input from user and including task details and constraints, and translate it by a COT-based agent into executable templates. We will deploy the agents defining these templates and the visualization their dependency relationships. And after executing all the system, we will output the results. And this is use case for with the waiting schedule task. And you can see this is our website, and here is input window to receive the natural language input from the users, and you can import anything you want, like information and the constraints. And then there is where you can choose some template we already constructed, or use our COT agent to create a template automatically. And you can see there are all details showing these about these agents, and you can click to show them for the expected output and response. And yeah, then in the right side there is the visualization of the dependency relationship of all these agents, and then just waiting to get the results. Then yeah, that's all the detailed results for each agent. And after this, we'll use another agent to summarize all these outputs and generate a final report, which includes the schedule and first part, and some key recommendations and some potential factors affecting its execution. So to evaluate the capacity of our system, we design a benchmark consisting of 13 problems. Among them, 9 are selected from the real and benchmark data sets, while the remaining 4 are customized design by us. There are HR interview scheduling problem and with disruption version, and the sports event scheduling problem, and with disrupting version. We test each problem on our system as well as on other state-of-the-art models like GPT-4o and DeepSeek and Cloud. For each task model pair, we conducted 30 runs and recorded the average pass rate of them. And you can see our system is outperformed than other single large language model. We believe our improved results from 2 key factors. First is our system design. We observe that single large language model often make mistakes when handling tasks such as producing has hallucinated or conflicting solutions, or failed in the progressing. The second is the use of well-constructed templates, because you can see, compared to version of our system, you can see the manual created template can increase around 24% of the pass rate compared to the COT agent-based Saga large language model. So this is our future development roadmap. First is to maybe to do the pre-trained template design model, do fine-tuning things if we get more data, and then the second task is to do the tool and API integration, help our agent system can invoke some real-world tools. And the final one is to do some cross-domain evaluation to test out with some NC scenarios to validate our system. Yeah, thanks for watching.